So yes, I'm Barry Stahl, and I like that. He's had a long career. I like that. That's a nice way of saying he's old, but it works for me. It works. So I'm a solution architect and developer. I'm based in Phoenix, Arizona, USA. I've been enjoying your beach, so thank you very much for inviting me here today. I'm here to talk about WebAssembly and Blazor, so I'm going to give you just a little bit about me, and then we'll jump into what WebAssembly is and why we might want to use it, and then we'll talk about Blazor and how that helps us use WebAssembly and do things like pushing AI models down to the client. So probably the most important thing you should know about me is that I'm the kind of person that has a list of his favorite physicists and favorite mathematicians. So that is probably tells you everything you really need to know about me right there, just that I would have such a list. But having such a list also means I'm the kind of person that loves to argue about such a list. So I've tweeted this list. My Twitter account is BS Stahl. This list is pinned to the top of it. So please look at it later. Tell me where I messed up. Tell me who should be on it that isn't, or vice versa. Right now, there is one person on the list that is kind of on the bubble. That's Neil deGrasse Tyson, and we'll see how things work out for him. The more I think about it, the more I think I really should pull him off the list and see what happens afterwards. So anyways, you can let me know on Twitter, BS Stahl. I'm also an open source contributor, and I run a number of projects, and here's a list of some of the projects I run. None of these are in particular relate to the topic today, so I'll only point out the first one, Liquid Victor. This is an experiment that I'm working on that is actually used to produce the slide decks that you're seeing today, which, by the way, is published up on the web, so you can pull it down. I tweeted the address to it, and you can pull it down right now if you want to follow along with it, or if you need them later. And I am the founder of Arizona GiveCamp. Now, GiveCamp is an international organization, and what we do is we hold events. They're basically hackathons where we put a bunch of software creators into a room with a bunch of local charities, and we hack for the charities over the course of a crazy fun weekend. I do not believe there is one here in Spain, so if any of you are interested in perhaps starting one nearby or wherever you are, let me know. I'll do what I can to get you information and as much help as I possibly can provide for you in that effort. So let's jump into WebAssembly, and let's just take a look at what WebAssembly looks like. So I'm going to switch over browser tabs here. Now, the interesting thing about this is if you go to webassembly.org, they have a tool chain that you can install. And so you can build C and C++ applications. And there's all these steps to installing it. And all I was trying to do was, kind of get close to the WebAssembly so I could feel what it was like. What does it take to build a program in WebAssembly? And so I start following all these instructions, and then you get to the very bottom, and it says, or you can try our web form here. So this is a pretty nice little playground here. They've added quite a few examples in recent weeks. I'm just going to start with this simple example. And this is a very, very simple WebAssembly program. This is written in WAT format, WebAssembly text format. And this is a program that, as you can see, it is a single module that exports one function, so that makes this function available outside of WebAssembly to JavaScript or whatever else might be out there. This function is called add2. It's exported as add2. And it takes two parameters. They're both int32s, and returns a single value as a result, an int32. And the function body is basically get each value off of the inputs. So each of the two inputs, get them and put them on a stack, add the two of them together, put the value back on the stack, and return that value. Very, very simple WebAssembly program. Now, WebAssembly is not designed for you to code it like this, but you certainly can. So what that produces for us is this build log. So the first 8 bytes right now are going to be always the same. The first 4 are the WebAssembly, they call it the WASM binary magic. These are the magic 4 bits that tell you this is a WebAssembly module that's being created. So those are null and then ASM. So that tells you it's WebAssembly. The next 4 bytes are the version number. So 1000, that's all we have right now. There is only version 1, although we are released now. So all 4 major browsers support version 1 of WebAssembly. And then it has a, we go through the type section. And one thing I want to point out, because it threw me a little bit the first time, is this byte 9 here. It says, right now it's 0, and it calls it a section size, and it says it's a guess. So it just fills in a 0 there for the guess of the length of this section. And then later on, it comes back and it fills that same byte 9 right here, fills that back in with a 7 once that section is complete and it knows how long it is. So it's just redoing that same one. So that took me a few minutes to figure out, so hopefully it won't cost you that effort. Down in the bottom left corner here, we have some JavaScript, and this is the JavaScript that is going to compile the WebAssembly that we have in the upper left-hand corner and do something with it. So in this case, we construct a WebAssembly instance, compile that module, grab the exported function, naming it add2 again. Now this could be named something different. It doesn't have to be named the same as what's in the WebAssembly module. And then we're going to just run a loop incrementing from 0 to 9, and we're going to call that add2 function, passing in the I value twice. So we should get 0, 2, 4, 6. And over in this output, you can see that we do. So that's okay. That's not all that interesting. Let's get a little more complicated with it. Let's add another method to this. I'm just going to copy this method and paste it back down here. And as you can see over in the build log, we no longer build because we have duplicate functions. We have a redefinition of the add2 name. So of course, I can't call 2 functions. I can't export 2 functions the same thing, so let's make this one add3. And we'll add a third parameter, and another int32, but we're still going to return a single int32. And now we have to actually add it. So local get 2, so I'm getting at the second index, so the third parameter, and then I32 add. And you can see we compile. So now let's go down here and grab add3. We're dereferencing that out of the list of imports, or exports, sorry. And then let's just call that function, add3, passing in I, and I. And in our results, you can see that we're now calling both the add2 function and the add3 function from JavaScript. And those functions are executing in WebAssembly. Pretty straightforward, right? So what is WebAssembly? WebAssembly is primarily a W3C specification. So this is a standard that the W3C created for a portable binary compilation target. So those are pretty important keywords there. Portable binary compilation target. It's a compilation target because it's designed to be compiled to from nearly any language. So whatever language you're working in, you should be able to get a compiler that can compile down to WebAssembly. Likewise, it's portable, so theoretically it can be run anywhere where WebAssembly is executed. It is not machine specific. It's not a native code. It's an abstraction level up from native code. But it's also able to support non-browser embedding. So I mentioned it's supported in all 4 of the major browsers right now. It also is going to be supported, if it's not already, in IoT devices and in other spaces. So ultimately what this makes it is really the intermediate language of the web. Where JavaScript is the scripting language, this is the intermediate language. This is the language that is a level of abstraction up from the compilers, from the browser compilers, and you'll see a diagram of this, but is at a lower level than JavaScript and can be compiled to from anything. What it gives us is a structured stack machine execution model. So the stack machine part you've already seen. We put some parameters on the stack. We took the two int32s that were put into the function. We took those, we put them on a stack. The add function within WebAssembly took the top two parameters off the stack, added them together, and then pushed its result back on the stack. Most instructions in WebAssembly do that. They use the stack to get their operands and to store their results. The structured part of that statement is that flow of control, there are structured flow of control constructions within WebAssembly. So the compilers don't have to handle all that flow of control. There are while loops and if constructions and things that can be used. So it gives us all that. What it doesn't give us is a very large type system. Right now, there's only 4 types available in WebAssembly. There's int32s and int64s, float32s, float64s. That's it. If you want to build strings, there are ways to do it, but they're not native types within WebAssembly. These are the different module sections. So we saw type 1 section. That was the very first section that was coming up in the upper right corner, that decompilation or that compilation step. Type 1 is, for example, where you would declare the signatures of your functions. So each of these sections will appear in a WebAssembly module, although not all of them are needed for every WebAssembly program. The key ones are the type function, as I mentioned, where you declare your functions, which is weird that they called it type. You know, it's like we needed another thing overloaded, another way to overload the term type. But so yeah, types right now are functions in WebAssembly. There's the export section. That's what makes things public to anything outside of WebAssembly. There's the code section. That's number 10. That's where you actually put the implementation of your functions. And then there's things like table, which is number 4, and memory, number 5, which are designed for creating data structures. So you can use those to, as storage space for creating strings or whatever other data types you need. And there are other sections as well. So I mentioned that WebAssembly is kind of the intermediate language of the web. One of the key design goals for WebAssembly was that it needed to work well within the web as it exists today. It cannot break the web. We've had other platforms, we've had other tools that have tried to create browser embeddings, but don't work well with the web as it exists. You know, I mean, think about Flash or Silverlight or any of those tools. You know, you had this entire other runtime that had to be loaded. You had all these additional security risks. One of the primary goals of WebAssembly was to not create those kind of problems. It needed to work well with the web as it exists today. So to do that, it executes in the same semantic universe as JavaScript. It allows synchronous calls back and forth between WebAssembly and JavaScript, and it enforces all of the same permissions, security policies, etc., that JavaScript supports. So if you can build it securely in JavaScript today, you can build it securely in WebAssembly today. And that's very important. It also executes in the same process space as JavaScript. So what you're seeing on the screen right now is the world as it existed before WebAssembly. All right, so now pay really close attention here because this is going to be drastic, right? You ready? This is what it looks like with WebAssembly. Boom. Should I do that a couple of times so you can see it? WebAssembly executes against the same compiler and runs in the same browser virtual machine as the JavaScript. So in theory, at least, the virtual machine that runs this code wouldn't even need to know whether this was JavaScript code originally or WebAssembly code. It doesn't care. It's running in that same process space. All right. So that's WebAssembly. How do we write code in WebAssembly, and how can we take the code that we have and run it in the browser using WebAssembly? So Microsoft's story for that, for those of us who are Microsoft web developers, is called Blazor. Blazor, there's actually two flavors of Blazor right now, and you can see both of them on this slide. There's a server-side implementation of Blazor, which is very cool. It does most of the work on the server side and uses SignalR to just update the DOM on the client side. That's very cool. But that's still doing all of the work on the server, or all the primary work on the server. If you were running an AI model there, you'd be running that on the server side. What we care about is client side for the purposes of this talk. The client side Blazor is where you can actually execute .NET code. So .NET Common IL running on the client side in the browser using Blazor. Now that is not available to us yet. It is a future thing. It is something we can do today, but only in preview. So the name itself, Blazor, comes from browser Razor. So Razor running in the browser. So Razor is what it sits on top of, and Razor is a syntax, a templating engine that runs on ASP.NET. So every Razor page is an ASP.NET page. So if you're familiar with writing ASP.NET, you're going to be fairly comfortable with writing Razor, although the syntax itself is somewhat different. But you can also have like ASP.NET MVC pages in the same project as Razor pages because it's all MVC, or it's all, sorry, ASP.NET. Okay? Razor itself has, compared to MVC, it has a simplified routing scheme where, you know, each page, the location of each page is its routing. You don't have to go through a lot of complex routing. You also have kind of a simplified layout because your HTML is in line with your script code. But as I mentioned, it can be used alongside MVC and often is on the server side because it's a good way of having, say, your API in the same project as your website. But in this case, we don't want to use anything server-side. I want to make just a plain old HTML website that I could run under any web server, like Nginx or whatever. I could run on a Linux server. That's just plain old HTML, but it's actually serving my AI model to the client. So how would I do that? Let's take a look at what Blazor looks like. So we're just going to go in and do File New Project for Blazor. So this is an installation of Visual Studio 2019 Preview. So this is the preview bits, which is what you have to use right now. So I'm going to say New Project, and I'm going to select ASP.NET Core Web Application. And we're going to go in the temp folder. We'll just call that Web Application 3. That's fine. And create that. Now, notice up here, we're selecting ASP.NET Core 3.0. This is also preview at this point. And you can see there's 3 Blazor templates here. If I go back into ASP.NET Core 2.2, there are no Blazor templates. Blazor will not work right now under .NET Core 2.2. It's got to be 3.0. And there are 3 templates. There's a server-side Blazor template. We talked about that. That's the one that uses SignalR to update the DOM. We've got an ASP.NET Core hosted Blazor, which runs under, runs under ASP.NET, mostly on the client side, but it will serve up plain old Blazor pages. So you can still run server-side or client-side Blazor using this template, but it's actually going to run a Kestrel web server on the server side to serve it up. What I want is this client-side Blazor, which creates just a plain old HTML website template. So let's select that and let it do all its building, and then we'll take a look at it and play with it just a little bit. Like all ASP.NET programs, we start in the program.cs, and you can see it constructs a Blazor WebAssembly host, and it says for startup, we're going to use this startup class, which you can see right below it over here. So let's go over to that startup class. And this is, much like any other ASP.NET web page, where we would configure our services. So this is our dependency injection right here. That's where we would configure our dependencies. Now, these dependencies, because they're going to be served in Blazor, they're actually going to be injected to our pages on the client side. I find that very cool. All right, what else? We've got some pages here. Here's our index page. So it says, hello world, welcome to your new app. And there's this survey prompt, and it has a title. Survey prompt here looks like an HTML tag, but that's not a regular HTML tag. So what it actually is a component. This is a Razor component, and this is the encapsulation model for Razor and Blazor. It's these components. So you can bundle up components with HTML and C# functionality and reuse them in multiple places in your app. So in this case, it says survey prompt, and it passes this title along. Well, let's make some changes here just so we can see them. JOTB19, so we're going to change the main page to say hello JOTB. And then let's go to the survey prompt. Here is our Razor page that is a survey prompt. And you can see we have some functions down at the bottom, and that takes a parameter called title. So you remember in the previous slide, that survey prompt, it sent title, and it had some data. What was that data? It said, how is Blazor working for you? But it's both upper and lower case. Well, that gets stored there, and it's going to get displayed right here. That at title, that's actually that title string from C#. And this is C# here, so I can do something like to upper and execute that C# before that gets displayed within that strong tag. So what we should see now is that title uppercased. Something else I want to point out in here before we run it is that there is this counter page. This counter page has this function where it sets a local variable that's an int, sets it to 0. You know, let's just set that to 5 just to start off with. It initializes, and it shows it here up in this paragraph. It shows current count. It just displays whatever we have in this current count variable. And then it has a button, and the on-click event for that button is this increment count method down here, which all it does is increment the current count. Let's see this run. You can do it, little laptop. Okay. So it's loading up here. It's running on my local host, but what it's doing is it's pulling the entire application, bundling it up and pulling the entire application down. This is a single page application framework, which we'll talk more about. So what that means is it's shipping the entire application down, and it is now loaded. So I could disconnect from the server at this point, and it would still run just fine because the entire application is loaded on in my browser now. So you can see we've got the hello J on the beach 19. We've got our title all uppercased, so it executed the toUpper function in C#. And then if we switch over to this counter page, you can see our current count is set to 5. And when I click it, it's incrementing. If I show you the browser tools and we look at, what would we look at? Network. You can see that as I'm clicking this and incrementing the count, there's no network activity here. All that script is running on the client side. So the script to increment that count and to redisplay it, that's all happening on the client side. C# code running in the browser. I find that cool. All right. All right, so what is Blazor then? Blazor is a single-page application framework, okay? For building client-side applications that run in the browser and use C# as their scripting language. So you could conceivably build any desktop application as long as it can work within the JavaScript sandbox. If it works within the browser sandbox, you can build any application and it will run completely on the client side. It uses the Razor engine and syntax, as we've talked about. The C# code is inline. You use these components that are reusable bits of functionality, and they can have both script and markup in them. And the real magic is this mono.wasm. Now, if you're familiar with .NET, you probably know Miguel de Icaza and his team that built Mono. They are now Xamarin and have now recently become part of Microsoft, or relatively recently anyways. They built an implementation of the Mono framework, which is an open source .NET framework. They built an implementation of that for WebAssembly. So mono.wasm is a WebAssembly implementation of the .NET framework that supports Net Standard 2.0. Now, Net Standard 2.0 is what I've been writing my libraries in for years now. Ever since we switched over from portable class libraries, everything I've been doing has been, all my library code has been written to Net Standard. So what that means is any code that I've written already that runs under Net Standard 2.0, that is compliant with that standard, can run under mono.wasm in WebAssembly in the browser. So I do a lot of AI demos, and I have this one set of demos that I wrote several years ago that is for playing, or it's for, a game agents, right? So they're playing the game Chutes and Ladders, sometimes called Snakes and Ladders. It's just a board game. It's a very young kid's game where you go up the board and you can climb up ladders or slide down chutes or whatever. Now in the real game, you don't get to choose, but in this variant, you get to decide, are you gonna take a chute or a ladder if you get to it? And these strategy agents in the bottom right corner, those are the ones that have to make the decision. So these are our intelligent agents that have to decide, they have to make decisions for us. The top level, the context here, because it was a demo, was a console executable. So I'd run an executable from my console on my machine, and it would call into this gameplay engine and execute a bunch of simulations of this game and see which strategies worked out best. And my favorite one is the genetic algorithm. It's a machine learning algorithm where it basically simulates Darwinian evolution in trying to find the best strategy to use. You define the DNA, and then you define how quickly that DNA mutates and how many simulations you're going to run, and the best strategies survive and mutate and reproduce, and you continue from generation to generation, and eventually the idea is that you end up with the best strategies. And I had a simulation of that in this library. And this gameplay and common and storage libraries, those are all Net Standard 2.0 libraries. So that means if I just replace this console executable at the top here with a WebAssembly with a Blazor single-page application, I can take those exact same DLLs, that exact same code, and run them in the browser on the client side and do all that work that run that genetic algorithm in the browser on the client side, on your phone if you want. And of course, I wouldn't be telling you that if I hadn't already done it. So let's take a look at actually what that looks like. And this code is all available for you on GitHub. There'll be a slide link at the end, and you can pull it down and play with it yourself. So a lot more projects in here. The Chute project, under the top one under UI, that's actually the console executable. So you can see that one running as well. Chute.web is the Blazor project. And we have a page that is the genetic algorithm. And so we have 3 parameters here: max generations, simulations per generation, and a misspelling rate. So how many generations are we going to run? How many simulations are we going to run per generation? And how quickly do they mutate? What percentage of the time does a gene mutate? And then if we click this button, it calls the run simulation method. You can see our 3 parameters here that are bound to those text boxes at the top. And this run simulation method just calls this evolution module, which is calling into the net standard code. So the same library code at this point, everything underneath this is exactly the same as it is for the console executable. So let's run this. Okay, so we're loaded up. Here is our genetic, our different parameters, and we can modify these as we need to. Now, I did mention that this was originally run as a console executable. So all the logging, everything that's actually output is output to the console. So, and I didn't go in and change that. So that means I need to show you the browser console in order for us to be able to see it actually doing anything. So I'm going to open up the browser console and then hit go. And what we're going to see is now that WebAssembly is running. And we're having multiple generations created. So each time, what it displays here is each time it gets more wins than the previous generation, it's going to show us that we had a new evolution, if you will. So now I'm only running 15 or so. Part of that is because it's demo, and part of it is because WebAssembly running this way right now is still much slower than it will be eventually, because we're running it interpreted right now. Mono.WASM is interpreting those same DLLs that are shipped down to it. It's doing that in the browser. But those are the exact same IL DLLs that would run on my machine. So I could actually copy those out of my browser, take those DLLs, put them in any project on my machine and have it run on Windows or whatever. They're the exact same DLLs. But that means it's running right now fully interpreted, so it's still fairly slow. Now Miguel's team is doing a lot of work to try and figure out what needs to be maybe pre-compiled down to WebAssembly. But of course you can't pre-compile everything because WebAssembly is such a small instruction set. Right? It's got only 4 types, so it doesn't give us a lot. So if you pre-compile that to WebAssembly, what you're doing is you're making it a lot larger. So now you've increased the speed of execution, but you've also increased the amount of time it takes to download it and to load it up, etc. So there's trade-offs there. And what happened is it executed and I just closed it. So that works. So it ran, it displayed the list of all the, here's what I found, here's the, at the end, it basically takes the original strategies and the newly found strategy, the best found one, and it plays games against them, runs that simulation, and then shows a comparison between the two of them. So you'll be able to look at it and see, here's what it originally looked like and here's what it evolved to once we're done. You see the power there? I mean, that's, I can host that. In fact, I've done that in longer demos. I've taken that and pushed that up to a Cloud Foundry instance where it's just running under a plain old Nginx web server. And then you could pull that down onto your phone and run it on your phone, or you can pull it down onto any browser and run it there. And I'm not paying for that CPU time. There's a lot of possibilities that opens up. All right. So, should you use Blazor right now? Obviously not. Right now, we've only very recently had the experimental tag removed from it. When it was an experiment, we were never guaranteed that it would ever see the light of day. Now they're promising us, since they've removed the experimental tag and now they're calling it a preview, they're saying we will ship it to you at some point, but we have no idea when. And the fact is, there still may be better ways to do this. There are several other projects out there right now that are looking at how can we run .NET in the browser, and it may be a better way. There may be ways to, for example, just take .NET IL and compile it directly down to WebAssembly IL. It'll make it bigger, but it may work better. I don't know. So there's still possibilities out there yet. I know this will be released, and I know this will be well used. There's a fairly large community around this already, and it is very vocal. If you go onto Twitter and you look for Blazor, there's a lot going on with it. The tooling is not perfect yet. I mentioned that they're still looking at how to do, what should be pre-compiled and what shouldn't. They're looking at a lot of tree shaking to reduce the size of things. So right now it's still too big. The debugging experience is not great yet, although it's gotten a lot better. So there's still a long ways to go yet before this is released and ready for full-on work by a development team. It's also really got very little benefit if you're fluent and comfortable in JavaScript, and if you don't already have .NET code that you want to execute. So if you have a .NET library and you need to execute that in the browser, this is probably the best way to do it right now. But if you're already comfortable with JavaScript, you don't have it already written, maybe you should write it in JavaScript. Certainly, this is not going to replace JavaScript for DOM manipulation. What I see this replacing JavaScript for is for CPU-intensive things. For example, image manipulation on the client side, or other CPU-intensive operations. So this was originally going to be one of those silly flowcharts that says, should I be using it now? No. But that was a little disingenuous, so I actually made you a real flowchart here, and it basically says what I just told you. I'm guessing 6 months, so as long as you don't have to release for the next 6 months, you may be okay using it, but only do it if it solves your pain. If you already have code that you want to run, or if you aren't comfortable doing what you're doing in JavaScript. So how do I get started using this? Well, number one, you install Visual Studio 2019 Preview. It actually right now has to be the preview bits. And you can get those from visualstudio.microsoft.com. And the preview works side by side with both Visual Studio 2017 and the regular full installation, the RTW of Visual Studio 2019. So you can have them all side by side, and it doesn't interact with each other. It doesn't mess anything up. I'll tell you, I have all three on this machine. I haven't used either the regular channel of Visual Studio 2019 or 2017 since I got installed, the preview of 2019. There hasn't been need for me to do so. You also have to have the latest .NET Core, which again is preview bits. So it's the .NET Core 3.0 preview. And there is a Blazor extension that installs the templates into Visual Studio for you. You don't strictly need that, but you kind of want those templates. So it's a good idea to have them. And then finally, all you have to do is file new project, ASP.NET Core Web Application, as you saw. And you'll get that template up, and then you can run it and manipulate make those changes and start playing with it. There's a lot of good resources out there, and I'll show you some of those on the next slide. So let's sum up here. WebAssembly, portable binary compilation target. So compile from anything, from any language, theoretically, to any runtime space. So it can run on any machine. That executes in the same browser context as JavaScript, or could also be installed in non-browser contexts like IoT devices. Blazor is a single-page application framework that uses C# for scripting and uses the Mono project, that mono.wasm, that is interpreted on the client side in the browser. So it's interpreting our .NET IL using that. I honestly see WebAssembly as becoming sort of the shared library language for all languages. I can see, because it can be compiled to from anything and is a W3C standard, I can see it kind of being, when you build a library for other developers to use, I could easily see people shipping that library in WebAssembly so that it can then be used by anyone in any language. We're not there yet, but I think we're going there. So I think it's going to be a good idea to be comfortable with using WebAssembly and having a path to WebAssembly for your code, especially if you're thinking about building libraries. So you can get to these slides through that URL here. And that, of course, has the links. You know, these slides they're active links here, so you can just click on the links and get to whatever you need to. The Chutes and Ladders simulation, as well as my other GitHub repos, are linked here. And then the WebAssembly tutorials at webassembly.org, the Blazor tutorials on Microsoft.com, and my blog, which is cognitiveinheritance.com. So it looks like we've got a few minutes left, so I'll be happy to take any questions. And thank you for listening to me.
Thank you so much. It was really interesting. I have 5 questions currently. The first one is, can multi-threaded .NET libraries and applications be executed in WebAssembly? So
it's WebAssembly right now is much like a lot of the front-end frameworks. It can handle multi-threading, but it doesn't really multi-thread it. Not at this point. It pushes things off of the UI thread. And you know, if you're doing async and await or the TPL type patterns, either of those will work, they'll run, but you won't get the full benefit of true multi-threading.
Okay. Second one is, what is the difference between WebAssembly and Blazor compared to tools that translate directly to JavaScript and execute it in the browser, such as Google Web Toolkit?
So I'm not that familiar with Google Web Toolkit, but if you're, so is that something that compiles JavaScript? Well, it couldn't compile JavaScript.
Translate into
translates to, so it translates some other language code into JavaScript. Okay, so then what you're doing is you're basically running JavaScript at that point. So that would solve the problem for you of, if you're uncomfortable writing in JavaScript, write in whatever language you're comfortable with. TypeScript is another way of doing that. For many of us who are C# developers, we're a lot more comfortable writing in TypeScript. And then you end up with JavaScript, or I'm familiar with like CoffeeScript or things like that. Yeah, and so anything that's translated into, that solves that one problem, but it doesn't get you down to that lower level compiled language. So eventually we'll have performance gains that you can really, in fact, if you really compile something down well to WebAssembly, it's going to run order of magnitude faster than JavaScript is. And that's really the big benefit at that point.
Another question is, can we interact with existing JavaScript code?
Yes, yes. There's full interop, and it's designed that way. It's designed to be completely interoperable with JavaScript. So as long as your JavaScript is usable from, if you could access it from other JavaScript that's outside of that library, you can access it from WebAssembly.
Can add functions blocks from CS/HTML be extracted to a separate file or something?
I think I get the, and it's not CS/HTML files anymore. Now they're .razor files, because they just wanted to make it difficult for me to change all my demos this morning. If you can easily, well, first of all, you saw that there's capabilities for doing dependency injection. So you can certainly inject your lower level libraries, but you can also pull off CS/HTML. You can have partial Razor pages. You could have partial pages, you can abstract them out in the same way as you can abstract out many other web libraries. So yeah, I don't think you'll find it lacking in that area.
And the last question is how good it is and how much it will be improved, the performance of Blazor in the future.
The performance is not there yet. It's not where I want it to be yet. It's too slow. And to some degree too large. So, but it's not production yet either. I have a lot of confidence in Miguel and his team. Everything I've ever seen from them has been amazing. And I have no doubt that they're going to produce something here that is amazing. But again, it won't be the right solution for everything. So it's, like everything else. Use it if it's the right thing for you. But yes, I do believe we will get to the point where the performance is what we want from it, and it's going to be a lot better than just native JavaScript.
Okay, that was all. So please give him a surrounded thank you.
Thank you.